This is our video on payout annuities. Here's the usual outline. We'll look at an example and the symbols that will be used. Most of these symbols will be familiar. We will look at the formulas for payout annuities. We'll look at some more examples. And then we'll use a spreadsheet or Desmos. We'll do both to do the calculations. And the final segment of the video is on why the formulas work. Payout annuities are similar to ordinary annuities, except with payout annuities you receive money. You begin with an initial deposit and you receive money. They're typically used after you retire. So the basic idea is that you have money saved, usually for retirement, and a payout annuity will pay that money out to you in equal periodic payments, usually monthly, until the money is gone. And the money that has not been paid out continues to earn interest. And as we did with ordinary annuities, we will assume that the equal payments take place monthly. Here's sort of a typical example. A couple has saved $500,000 for retirement. They are going to put the money in a payout annuity that pays 4% annual interest, compounded monthly. And the annuity will make equal monthly payments to the couple for 25 years. And at that point, at the end of 25 years, the money will have all been paid out. So what will the monthly payment be under these circumstances? So here are the symbols. P is the beginning value of the annuity. That symbol is probably familiar. In our example, P is $500,000. A is the amount of money remaining in the annuity. So A is an amount that will change over time as you receive payments. In our example, A will start at $500,000. That's how much the couple deposits in the annuity to start, and A will end at $0 when the payments stop at the end of 25 years. R is the annual interest expressed as a decimal. R is 0.04 in the example. T is the life of the annuity in years. T is 25. And PMT is the monthly payment to you. So all these symbols have been used before for similar things in other circumstances. In the example, we want to find PMT. We want to find what the monthly payout to you will be. And we're always going to assume that interest is compounded monthly and that the payments are made monthly, just as we did for ordinary annuities. There are 4 calculations that we will be doing with annuities. The first is, given the beginning amount, $500,000 in the example, and given the annual interest rate, and given the life of the annuity, we might want to find the monthly payment. Another possibility is, given the monthly payment that you would like to have, given the life of the annuity in years, and given the annual interest rate, find what the beginning amount of the annuity must be. We will see examples of both of these kinds of problems. And then 2 other calculations that we'll be doing. The total amount of money you will receive over the life of the annuity, and the total amount of interest that the annuity earns over its life. And now the formulas. If you want to calculate the monthly payment to you, PMT, and you know the beginning balance, capital P, the interest rate R, and the time in years, T, that is the life of the annuity, then this is the formula for how much you will receive monthly. If you know how much you will receive, you want to receive monthly, and you want to know what the initial value of the annuity has to be, then this is the formula for calculating the starting value of the annuity given the payment you want to receive, and the interest rate, and the time in years. So this second formula is really just obtained by solving the first formula for P. Just a little bit of algebra involved there. The total amount of money you will receive, you simply multiply the monthly payment times the number of months it's paid out. That would be 12 times the number of years. So the monthly payment times 12 times the time in years will give you the total amount of money you will receive from the annuity. And the total interest earned by the annuity is simply the amount you received minus the amount that you paid in. And as we saw in item 3, the amount you received is PMT times 12 times T. If you are doing these calculations either on a handheld calculator or using a spreadsheet or on Desmos, put in all the parentheses, especially if you're in doubt. So let's go back to our example where P is 500,000. The life of the annuity is 25 years, and the annual interest is, in decimal form, is 0.04. So to find the monthly payment to you from this payout annuity, we're simply going to plug into the formula for a monthly payment, which I have reproduced here. And then I have plugged in $500,000 for P, 0.04 for R, and 25 for T. And I have done the calculation. The answer is $2,639.18 per month is what you will receive if you have saved $500,000 and you put it in a 25-year annuity, paying 4%. How much money did you receive altogether? This is the payment you receive monthly times the number of months you were paid, as we noted before. So the total amount of money paid to you is the monthly payment to you times the number of months times the number of years. Times 12 times the number of years. Number of years is 25 in this case. So over the life of the annuity, you will have received $791,755.26. All the figures are rounded to the nearest cent. How much total interest will the annuity have earned? As we saw before, the total interest earned is the total amount you receive, payment times 12 times T, minus the amount you put in at the beginning. The monthly payment is $2,639.18 times 12 times 25. We did that calculation before to find the total amount you will receive, and then we subtract the $500,000 initial investment. That calculation gives $291,755.26. So these calculations and all the rest of the calculations in this presentation I did on a spreadsheet, which I'm going to show you later in the video. As we have seen earlier, these spreadsheets can be downloaded from the class website. One more encouragement to you to use a spreadsheet. This will be a big time saver when you're doing homework and quizzes. Okay, so let's try an example where we know the monthly payment. So imagine you have retired and or you're planning on retiring, and you know how much money you would like to have per month. You know the interest rate and you know the life of the annuity. We want to find how much you will have to invest in the annuity to get the monthly payment that you want. So here's an example. Say you can invest in a 20-year payout annuity that has an annual interest rate of 7%, and you would like to receive $1,000 per month from the annuity over its 20-year life. What does the starting value of the annuity have to be? Well, this is a problem where we want to find P. We want to find the beginning value of the annuity, and then we know the other figures. We know it's a 20-year annuity earning 7% annual interest, and you would like a monthly payment of $1,000. So we plug into the formula for P, which I have reproduced here. We're replacing PMT by 1,000, R by 0.07, and T by 20. If you do that and do the calculation, you get $128,982.51. This is what you would have to deposit initially to receive a payout of $1,000 per month. And now, how much money will the annuity pay you altogether? This is assuming that you start with the required amount. So the formula is total amount of money paid in, your monthly payment, total amount of money you receive, paid to you, that is the monthly payment times 12 times the number of years. The monthly payment is 1,000, number of years is 20. $240,000 will be the total amount of money paid out to you over the life of the annuity. And how much of that is interest? Well, the total interest is the amount paid out to you, your monthly payment times 12 times the number of years, minus the amount of the initial investment. It's $1,000 times 12 times 20, minus the initial investment of $128,982.51. The total amount of interest earned by the annuity over its lifetime is $111,017.49. Okay, so I'm going to do the two problems from the previous slides using a spreadsheet. This will only appear on the video. So if you want to see this done, you'll have to be watching the video. Here is the first of the two problems. The initial investment is $500,000. T was 25, and the interest rate was 4% or 0.04 if you express it as a decimal, and we wanted to find the monthly payment you would receive. So we go to the Canvas Math 110 homepage, and we click on this link, Spreadsheets and Other Calculation Aids. That takes us to this page with links to the various spreadsheets and formulas if you are using Desmos to do the calculation. And in this case, we want the spreadsheet for payout annuities. It's the third bulleted item. So I click on the spreadsheet for payout annuities. The spreadsheet appears, but I want to download that spreadsheet, so I'm clicking on Download Payout Annuities.xls. Since I have the spreadsheet program LibreOffice on my computer, I have the option of opening the file with LibreOffice, which is what I'm going to do. If you have another spreadsheet installed on your computer, you will probably get the option of opening this spreadsheet with that spreadsheet program. I click OK and open the spreadsheet. The problem we're doing, we want to find the monthly payment. For the second problem, we will be trying to find the required beginning amount, and for that problem we will use the bottom half of the spreadsheet. But for this problem, we are plugging in the known values. The initial deposit is $500,000. Which I enter here in cell B4. The annual interest was 0.04, and the life of the annuity in years was 25. And now the answers that we're looking for appear here. The monthly payment here in cell E7. As we saw, monthly payment to you will be $2,639.18. Here in cell F7 is the total payments to you, and here in cell G7 is the total interest. Not much to that if you're using a spreadsheet. In the second problem, we knew the monthly payout we wanted to receive, $1,000. The life of the annuity was 20 years, and we had an interest rate of 0.07, and we wanted to find the initial investment required to get this payout. So we're going back to the same spreadsheet, and we will be using the bottom half of the spreadsheet, where we have to enter the interest rate, which in our case is 0.07. We have to enter the time in years. For our problem was 20. And we have to enter the monthly payment that we want, $1,000. Hitting the return key gives us the amount of the initial investment required. The total of the payments made to you, and finally the total interest. Again, a fairly quick calculation. Let's go back to the first problem again and do the calculations using Desmos. So here we want to go to the Spreadsheets and Other Calculation Aids page, where we found a link to the Payout Annuities spreadsheet. But now let's go down to the formulas for use with Desmos. we want this formula. It's the fourth bulleted item in this list for calculating the monthly payment in an annuity given the ending value. So I'm going to highlight this formula. Copy the formula. That's up to the menu line under Edit, and I want to copy the formula. And now I want to open up the Desmos online calculator. In the first calculation box, I'm going to paste the formula that I just copied to my computer's buffer. So I'm going back up to Edit on the menu line and clicking Paste. So the formula appears. And now we have to fill in the values of A, R, and T. Sorry, I had copied the wrong formula. Now I have the correct formula copied, and I will paste it into the first calculation box on Desmos. Edit, paste. So there's the formula for the monthly payment of a payout annuity, and now we have to fill in the values of P, R, and T. As we've seen in previous examples, the way you do that is to click on the All button, which gives default values to P, R, and T. They're all assigned a value 1. But in our problem, P is 500,000, so I have to replace the P, the 1, by 500,000. R in our example is 0.04, so the 1 has to be replaced by 0.04, and T in our example is 25. And now the correct value for the monthly payment appears here in this in the box in the lower right corner of the first calculation box on Desmos. If you have a Desmos account, and it's easy to get a free Desmos account, you can save this formula. First of all, we will title the graph. Whoops, I'm not logged in. First of all, we will title the graph Payout, and then save it. And now for the reasons that the formulas work. So in order to see why the formulas work, we're going back to our first example where you invest $500,000 in a 25-year payout annuity at 4% interest compounded monthly. And as usual, as always in this course, the annuity will make equal monthly payments at the end of each month over a period of 25 years, and you want to know what the monthly payment will be. So for the remainder of this explanation, I'm going to leave it on the slides, but not put it on the video. So to see why the formulas work, you can access the slides for this video.